Alrighty, page 44. So this is just a continuation of what we did yesterday. Yesterday we talked about a lot of stuff with rationals and graphed one and talked about radii, right? But one thing we didn't talk about with rationals yesterday was slant asymptotes that we know exist, that we have talked about before. So this just kind of continues and adds that to the whole thing. So this is a recall because, again, not new. If the degree of the numerator is 1 greater, just 1, that's when we get a slant asymptote. What's another word for slant asymptote? Oblique. And that could be, you could see it and hear it either way on the AP test, so you just got to know that they're the same thing, okay? So here's our function. They've given us the graph. By looking at the graph, we can see that we have a vertical asymptote. We can see that we have a slant asymptote. We can see that we have a point discontinuity or a hole in there as well, right? We should be able to get all this stuff off of the graph just like we did yesterday, including the equation of the slant asymptote. I mean, I know that they end up giving it to us, but that is an equation of a line that you should be able to write. Remember I told you when we're writing equations of lines, if we're going to use point slope form, not slope intercept form, okay? And if you get those names mixed up, y equals mx plus b, I know is what you're more familiar with, but that is junk unless you are straight up given the y-intercept. Are we straight up given the y-intercept? Do you feel like yes on here on the graph? Yes, okay. I mean, it's not a guess. We really shouldn't guess off the graph, but I don't think that would be a guess here, especially if they were asking us for it. So that should be a line that we could actually write the equation of. So I get y equals some slope times x plus the y-intercept, which is 1, right? What's the slope of the line? 1. It's a positive 1, right? Up 1 over 1. So this is the equation of my line. It's that easy to write, okay? If we didn't know the y-intercept, then we'd use point slope, but there is a place for y equals mx plus b. This is something we should be able to get from there, right? So this is your slant asymptote. Then, of course, you should be able to tell that your vertical asymptote is at x equals what? -1, okay? And it does go on to tell us all of this stuff. So as we look at this, because, again, it's just kind of giving us an overview, this is the function here that is actually graphed, okay, and it's factored for us. So because it's factored like this, we can see that there's a hole at x equals 2, right? And a vertical asymptote of x equals -1, which we already figured out, but we could also figure out from the equation. And then it does not have a horizontal asymptote, but does have a slant asymptote. And again, we've already figured out where that is. The reason it has one is because the degree of the numerator is 1 greater. Notice it shows the degree of the numerator is 3, denominator is 2, which is when we look at the original, clearly that's what it is. If I was going to actually find it not from the graph, but by division like we know how to find it, yes, I could do it from my original, which is totally fine. But if I'm going to factor and get rid of the whole anyway, then this is a simpler form, right? But I would want to multiply it back. So once I cancel these out, my actual, oh, this is not f of x, it's k, so let's use the right thing. My k of x, when I multiply it back, this would give me x squared plus 2x over x plus 1. Then that's the one that I personally would choose to divide. Again, whether I divide this one or I divide this one, I'm going to get the same answer, but wouldn't you agree that this one would be a little bit nicer, right? And still, the numerator is just 1 greater than the denominator. It just wouldn't be 3 and 2, it would be 2 and 1, but the same thing works, because once you cancel it out, it's still just 1 greater, no matter what it is. All right, and so we're going to talk about long division. We've already done long division. I did that separately with you, but it shows up on here again, and I didn't take it off, so we're just going to talk through this again. So for those of you that were already rock stars at it when we started, good for you. For those of you that might have struggled a little bit, then this might help you a little bit again. But, and this is really kind of the same way I had introduced it to you. We're going to start with the old method, like what you learned in elementary school. 676 divided by 21. So I'm going to take that 21 divided into 676. Okay? So what you learned in elementary school at some point, I don't know what grade level it is, and it doesn't really matter, but we're to divide this in here. It's not something anybody expects you to just know. That's why we know how to do long division. I would take 67 and divide it by 21. How many times does 21 go into 67? 3. Okay, so I put the 3 above the 1's place there, multiply it back, that gives me 63. Then we're subtracting, so the way I want you to think about it is we're going in and we're changing the sign, okay, because that's what we're going to do on the other. Then the 6's 0 out, this is 4, I bring down this 6. 46 divided by 21, well, that goes in there twice, so then that gives me 42, 2. And then I change my sign, right? These cancel and I get 4. Okay, so once I get to this point, let's go fill out what's down here. My quotient is 32 with a remainder of 4. Okay, that's what we get from our long division, right? So technically what's happening, and probably you've never really written it this way when you did long division like this is 32 plus 4 over 21. Because that's, again, technically what's happening. We have 32 plus 4 21sts, 21, I don't even know how to say that, to be honest with you. But is that the way we really write mixed numbers? No. We really write that as 32 and 4 over 21. But what it means is we're adding that fraction to that number. We just don't technically write it like that, okay? So if you take that same concept and apply it to your polynomials, so we're going to take 2x plus 1 and divide it into 6x squared plus 7x plus 6. Okay, let me rewrite that so I can actually have room to work. Sorry. 2x plus 1 and divide it into here. There we go. I was trying to go up as far as I can so I can write bigger. 6x squared plus 7x plus 6. There we go. So what's different is, over here, I took the entire 67 and divided it by the entire 21. Okay, but those are just, again, kind of one-term thing. Over here, that's not what's happening. Over here, I take this first term and divide it by that first term, right? So I take 6x squared divided by 2x. What does that give me? 3x. And that goes above my x term. Where you line it up is important. Multiply it back out. 6x squared plus 3x. And then I go in there and I change the signs. That's a step that some of you forget sometimes, and it's super important. Those 0 out. 7x minus 3x gives me 4x. And I bring down my positive 6. 4x divided by 2x is a positive 2, so don't forget the signs in your answer up there. Multiply it back, I get 4x plus 2. Go through and change my signs. Then those 0 out, and I get a 4. So then, oh my goodness, this board stresses me out. Goodness gracious, there we go. Okay, so my quotient, 3x plus 2, right? My remainder is 4. So the way we write that is 3x plus 2 plus, just like we added over here, 4 over 2x plus 1. But that one stays with that plus sign, otherwise it wouldn't make any sense, right? So we are rock stars at this, yes? Beautiful, okay. I knew I probably could have just skipped that part, but figured why not, it was already there. All right, so then on example 6, it says, use long division to find an equation for the slant asymptote h of x. So if I was doing this to actually, so this is my division, this is my actual answer, right? Just straight up long division. If I was doing this to find the equation of the slant asymptote, do I use this entire thing here? No. What do I do with the remainder? I leave it out and just ignore it, right? So that means I don't even have to kind of finish the whole thing. So I want you and your crazy good long division skills to go ahead and find the equation for the slant asymptote in example 6. Okay? You can do it. Okay, so then, is my answer 3x minus 1? Why not? I need to put y equals. I am looking for an equation. So on the other part, it was just straight up long division. I am looking for equation. I absolutely have to have y equals. Is it okay that I didn't finish my long division? 100%. Now, my suggestion to you is this. After I get this negative 1 up here, I don't even have to write this line. My suggestion is you go ahead and write that line, because when you multiply it back, you need to see that these are going to zero out, because if they don't, something went wrong. So just kind of as a safety net, maybe you writing that to see that it's going to zero out, then you don't really care what the rest is. But you can just know that you didn't do something weird with a number or whatever. Okay? We all good? Whew. We all good with that? Perfect. All right, so let's look at example 7 here. All right, so it says, find the equations for any asymptotes to the graph, and it gives us specifically what we want. The first thing we want is the factored form. There's not enough room for me to write my factored form there, so I'm going to write it, well, maybe. I'm going to write it over here so I can write bigger. So g of x, and I'm going to factor it. Remember, you need to be able to factor quickly and accurately. Now, if you have to write extra steps than what I write, it's totally fine. But if you look at the numerator, we have a GCF, right? What's my GCF? X. So I'm going to write out my x. Now, I'm not going to rewrite it with x factored out, because I feel like I can look at that, pretend like my x isn't there, and go ahead and factor the rest of it. If that is just, you know you'd mess up if you did that, it's fine. You can write a couple steps. It doesn't bother me a bit. But this is x, x. 12 is negative, so my signs are opposite. What's my positive number? 6 with a negative 2. Denominator, no GCF. So this is x and x. 6 is positive, so the signs are the same. 7 is positive, so they're both positive. What are my numbers? 6 and 1. Beautiful. Okay, so there is my factored form. So then it asks me for my vertical asymptotes. Do I have 2 of them? No, I only have 1. Now, does it ask me here anywhere for a point discontinuity or a hole? No. Do I still have to pay attention to that? Absolutely. So this is going to cancel out, which makes my reduced form x times x minus 2 over x plus 1. Okay? That's the form that I'm actually going to use to answer the rest of the stuff. I don't have to write out what my point discontinuity is anywhere because nobody asked me. That's fine, but I can't completely ignore it. So that shows me now I have 1 vertical asymptote, and that's at x equals what? Negative 1. Where's my horizontal asymptote? There isn't any. Why? It's top heavy. Very good, because I have a slant one, right? So this is none, and keep this in mind. You will never have both of these, because the only way you can have a slant is if it's top heavy, and if it's top heavy, it has none, so you can't have none and have one at the same time. Make sense? So if one of them, if you have horizontal asymptote, you don't even have to check for slant and vice versa. But you have to answer the question. I have none, right? So now my slant asymptote, and I know for sure it's a slant and not a quadratic or anything else because the numerator is just 1 greater, right? And then in order to do that, in order to find that, I need to divide. So in order to divide, I need to multiply this back. So again, I could use this version if I wanted to. But personally, I feel like using this and multiplying it back out is going to be a little bit easier to do. Would you agree with that? Now, could I divide this one using synthetic division? Yes. Could I have done that here? Yes. Do I care which one you do? No. But if you're going to do synthetic division, you better make sure you really remember all the rules. Because remember, I told you, if you only know one way, long division is the way to go. Okay? And really, when it's this simple, long division is not that big of a deal. Okay? So go ahead and find your slant asymptote, however you want to do it, as long as you can do it correctly. I'll do mine when I show you with long division, just because that's probably the safer way. Regardless of which way you do it, do you have to have a placeholder? Yes, because you are missing the constant term. So again, whether it's synthetic division or long division, you still have to have that placeholder. So don't forget about that. Okay, so I want you to see that the role that the placeholder plays here. Because if you'd have left off this 0 and you ignore that right there, then you may think you're just going to stop at x, and that's not correct, right? And so you need that there so that you can continue on with that. And again, I don't have to finish all this off. So I get that, whether I get this with, again, synthetic division or long division. So is my answer x minus 3? No. What do I need? Y equals, because it is a line and we have to treat them as lines. Okay? What questions do you have? Okay. So then I want you to read example 8, and I want you to think through it and work through it with the people at your table. I want you to talk to each other. Okay? See if you can figure out what you think your answer is here on number 8. I'll give you a couple minutes to do that. Let's talk about this. How confident are we on our answers? Very confident. Okay. All right. So they give us this function. It says, which of the following about the graph of d of x is correct? And so if you just look at your answer choices before you do anything, you have 2 that talk about horizontal asymptotes and 2 that talk about slant asymptotes. Can you have both at the same time? No. So when you look at this, is this top heavy, bottom heavy, or tied in degree? Top heavy. So what can we go ahead and eliminate? A and B. And if you can't figure anything else out, you have now narrowed it down to a 50-50 shot. If you have to, hopefully we don't get to this part or this point, but you pick your favorite letter. Now, the whole idea of always pick C, not necessarily the case. It really never was. But you should, for probability purposes, always pick the same letter. Now, so that's why I would go, then pick your favorite letter. Now, of course, if you decided before you started that your favorite letter is A, don't choose A here, obviously. Pick a second favorite letter. And you just 50-50 shot, right? But again, we don't want to answer questions that way. So just because it's multiple choice, does that mean that there is 0 work to be done? Not necessarily. Sometimes, yes. Now, when you look at what you have left, your answers have like 1 hole and 1 vertical asymptote or no holes and 1 vertical asymptote. So when you look at the denominator, I know it's an x squared. So if I factored that, then I'm going to have 2 things in the denominator. So chances are pretty good I'd either have 2 holes or 2 asymptotes or 1 of each. So C's looking pretty good. Would you agree with that? Okay, but let's actually do some work here. So just because we shouldn't always just work things out that way either. So if I actually factor this, they very nicely already factored the numerator for me. Then the denominator, I would imagine most of you would probably factor it like this, which is totally fine, and you get a -1 and a -1. Now, are things going to cancel out? Yes, okay. But if they didn't, then should I rewrite the denominator differently? Like officially, and since it's going to cancel out, it doesn't matter. But shouldn't that denominator really be x minus 1 quantity squared? Yes, okay. So, I mean, again, it's fine that it's not right here, but all right, so then once I see this, this is going to cancel out. So it really looks like I have a hole at x equals 1, right? Then when I look at this, it looks like I have a vertical asymptote at x equals 1. Can you have both? Which one dominates the other? Vertical asymptote. So you don't have that. Do you have any holes? No, you have no holes and 1 vertical asymptote, and your answer is D. I love the confidence that some of y'all did have with, I totally could have done that in my head. Good job doing it in your head, you got it wrong. But I understand your logic, because did you have the same logic I did before we did work? Something like that? Or even if you did that and you saw, oh, a hole cancels out, and I have a hole there, so it can't be D, but you don't really have a hole, make sure you are paying attention to the entire thing, okay? Y'all just fell into the trap. Congratulations. All right, not everybody did. I saw right answers around, but I saw a whole lot of wrong answers, so I don't know where that went wrong, but again, that's why these questions are asked this way. So be careful. These AP tests, they are not your average multiple choice test. Are you able to eliminate things sometimes? Absolutely. Are they going to be where you can always eliminate everything easily without thinking? Probably not, okay? Because there's a difference between just a multiple choice test and a very well-written multiple choice test, and these are very well-written. I'm not saying that they're tricky, but I am saying you have to actually think and just don't take it for granted that it's multiple choice, okay? The multiple choice parts can actually be more difficult than the rest. All right, so let's look at example 9. So here's where we have to sketch something from scratch, and I know none of us love these. So this is not multiple choice. They're telling us 4 things. So they're telling us the limit as x approaches infinity is negative infinity, and the limit as x approaches negative infinity is infinity. Do you know what this is telling you your function has? If I'm going to, as I go to infinity, my function's going to negative infinity, and as I go to negative infinity, my function's going to infinity, am I going to have a horizontal asymptote? The answer to that is no. So let's talk about what limits would look like for a horizontal asymptote, because it's been a minute since we've done that. So for a horizontal asymptote, which is not what this question's asking, but this is a good thing for us to have down here. If I have, so let's just say that I have a horizontal asymptote right here, okay? And this deals with end behavior. So I don't even care what's happening in the middle, okay? But because I have a horizontal asymptote at going to infinity, it's going to look something like that maybe, and negative infinity looks something like that. I don't even care what's happening in the middle and where my asymptotes and holes are. But if I have a horizontal asymptote, then my limit as x approaches infinity of this function is not going to equal infinity. It's going to equal a number, like let's pretend that this is 2. Because as x gets bigger and bigger and bigger, my function is approaching 2, whether it's approaching from the top or the bottom, but same thing for negative infinity. Does that make sense? So if you're in behavior, and you know it's in behavior because of the infinity, if your in behavior is approaching a number, you have a horizontal asymptote. Here, this is saying that the limit as x approaches infinity. So as we're going to infinity, the function's going to negative infinity. And as we are going to negative infinity, the function's going to infinity. So this tells me my end behavior. What is this thing on my graph? That's a slant asymptote or an oblique asymptote. Okay? If your end behavior approaches a number, it's a horizontal asymptote. If it approaches the infinities of either kind, then it's a slant asymptote. These specifically tell me not only is it a slant asymptote, but it's a slant asymptote with a negative slope, right? Because of what's happening there. We okay on that? That makes sense to you on that part? All right, so over here, it says the limit as x approaches negative 1 from the left, we're going to negative infinity. Negative 1 from the right, we're going to infinity. So here we are at negative 1. As I approach negative 1 from the left, I'm going to negative infinity. Negative 1 from the right, I'm going to infinity. What's happening at negative 1? Vertical asymptote, right? So this tells me I have a vertical asymptote at x equals negative 1. So very specifically, I can talk about the vertical asymptote. My slant asymptote, the only thing I know is that it has a negative slope, okay? Everybody okay with why it's a negative slope? Do we know exactly where it is and what the slope is? No, okay, but that's okay. So then we're going to sketch this. So let's sketch what we can right now. We know that we have a vertical asymptote at negative 1, okay? And then we know we have a slant asymptote with a negative slope. I have no idea what the y-intercept is. I have no idea what the slope is, and that's okay. This is where you get a little bit of liberty in what you're graphing, which I know sometimes makes you uncomfortable because you feel like maybe you should know more. But I can just throw in a line or an asymptote with a negative slope, and that's really all that I know right now. Now, if it had given me some other numbers or something else, maybe I'd know something else, but I really don't know anything else. The other thing I know, though, because I got to get some sort of graph in here, is that, again, what's going on around this asymptote. Oh, wait a minute. Look what I did. Y'all didn't stop me. Is this right for this? Good Lord. Y'all don't even say anything to me. All right, let's fix that so we're not totally confused. Because maybe you are totally confused now because I did that. I don't even know what I said. I don't know if I said the right thing and drew the wrong thing. I don't know what happened. But as I approach, let me go back. As I approach negative 1 from the left, I'm going to negative infinity. As I approach negative 1 from the right, I'm also going to negative infinity. Now, it does not change this, but it does change what the graph looks like, right? Sorry about that. You with me now? Speak up when I have a brain fart, okay? All right, but I caught myself because I was about to do something weird over here. So what I know, because I was looking at this, as I approach negative 1, my function's going to negative infinity. And as I approach -1 from the right, I'm also going to negative infinity. Now, that's not the entire graph, right? But there's things that I don't know. I don't know what my x-intercepts are. I don't know what my y-intercepts are, or my y-intercept. I can't have more than one. Could this function go up here and then cross the slant asymptote and then come back down? It totally could. Now, it can't cross the slant asymptote and keep going like that. That doesn't make any sense. But it could cross the slant asymptote, but then it still has to be approaching it because that's the whole idea of an asymptote, right? But we don't know any of that, and we don't have to get fancy. We just have to sketch something that it could possibly be. So I can just follow my asymptotes like this. I can follow this one like this. And as long as when I'm done, that has the properties that it listed out for me, I'm good. Okay? Everybody okay with that? On the AP test, the chances of you having to actually sketch one of these from scratch like this, pretty slim, I would imagine. I haven't seen anything like that. But the reason we do questions like this is because it can give you these properties and then give you a graph, and you still have to come up with those things. So you need to be able to think through it that way. And if you can sketch something, then you understand what's going on and you can make sense of it. Okay? We okay with that? All right, so then I'm going to talk to you about your assignment before I hand it to you. Because I know once I put a piece of paper in your hand, nobody's listening to me, and I don't want to answer these same questions over and over again. So this is what this looks like. Now, at the beginning of this, it's asking you for all these things, very similar to what we did yesterday, and you're going to have to sketch it. Now, it's not as vague as what we just did. It's more like yesterday where we actually had zeros and we actually had that stuff. You don't even have paper in your hands, and you're still not listening to me. Shush it. Okay, so my suggestion to you would be off to the side or wherever you want to do it. I would write PD ready like we did yesterday to make sure you have everything you need to actually sketch it. Because one thing it doesn't ask you here for here is the y-intercept, and you're going to have one here that you need to graph, okay? The next thing is down here. Now the numbering is weird, but get over that. I did that so you wouldn't have another quote packet. On 1 through 6 on the bottom here, it just says determine if the following rational functions have a horizontal slant or neither. You don't have to actually tell me what they are. So this should go very quickly. You just tell me if it's horizontal, slant, or neither, and move on. Okay, you'll have to actually find them on some other things. Does that make sense? But I just wanted to remind you that radi exists, PD radi, and you might want to actually go through and make sure you find everything that you need to be able to sketch this. And I think you'll be able to sketch it just fine. Okay?